Titan has always felt like a place that shouldn't exist. A moon wrapped in a dense orange atmosphere. Rivers, rain, lakes, and seas, but not made of water. A world so cold that ordinary life, as we know it, should be impossible, and yet so chemically rich that scientists have never been able to stop thinking about it. For years, Titan was treated like one of those distant, fascinating maybe worlds. Strange, beautiful, probably dead. But James Webb has now looked into Titan's atmosphere and found signals that make that old comfort much harder to hold on to. Because what Webb found does not fit cleanly into the version of Titan we thought we understood. And when you combine those new clues with what earlier spacecraft already saw, the question stops being whether Titan is weird. The question becomes whether Titan is hiding something far more radical than anyone wanted to say out loud. Most people hear moon and imagine something silent, airless, and geologically tired. Titan is none of those things. It is the only moon in the solar system with a truly thick atmosphere, even denser than Earth's, dominated by nitrogen and filled with methane that behaves the way water behaves here. On Titan, methane evaporates, forms clouds, falls as rain, carves river channels, and collects in lakes and seas. Strip away the chemistry and the temperature, and parts of Titan look uncomfortably familiar, like Earth translated into a language of ice and hydrocarbons. That is what makes Titan so dangerous to ignore, because it is not merely a frozen rock drifting near Saturn. It is an active environment where chemistry has been running for billions of years. Sunlight breaks methane apart in the upper atmosphere, and those fragments recombine into increasingly complex organic compounds. Over immense stretches of time, those compounds drift downward and coat the surface in a haze of prebiotic material. Titan is not empty in the chemical sense. It is saturated, and that alone already made Titan one of the most provocative places in the solar system. Not because anyone had proven life existed there, but because Titan kept producing the sort of chemistry that makes scientists deeply uncomfortable in the best possible way. The kind that says if life can emerge under radically different conditions, this is exactly the sort of world where you might miss it by assuming too much about what habitable is supposed to look like. What James Webb did was not dramatic in the cinematic sense. It did not land. It did not scoop up a sample. It did not photograph creatures moving through methane rain. What it did was something quieter and, in many ways, more unsettling. It read Titan's atmosphere in infrared and started identifying molecules that forced the question of biology to become more serious than before. Among the signals was a molecule tied to more advanced organic chemistry, the kind of chemistry that on Earth sits upstream from the molecules life eventually depends on. That alone was enough to raise eyebrows. Then came the carbon dioxide result, a molecule whose presence in Titan's chemically reducing atmosphere is difficult to explain cleanly without invoking either unusual chemistry we still do not understand or processes that start sounding uncomfortably close to biology. Not proof, but no longer easy to brush away either. And then the story became stranger still. Webb detected an additional lower atmosphere spectral signature that does not match anything cleanly cataloged in existing databases. Something is there. It appears consistently. It survives independent observation. But what it is remains open. That is the kind of result scientists treat very carefully, because unknown chemistry can mean many things. A new abiotic pathway, a familiar molecule in an unfamiliar state, or something that does not fit current expectations at all. Titan is not giving us a conclusion. It is forcing us to admit the old picture is no longer sufficient. What makes Webb's findings so hard to ignore is that they do not stand alone. Years earlier, another spacecraft had already found two deeply disturbing anomalies on Titan. First, hydrogen appeared to be flowing downward through the atmosphere and vanishing at the surface at a rate that known abiotic chemistry struggled to explain. Second, acetylene, a compound expected to be present on the surface in abundance, was mysteriously depleted. Taken together, those two clues pointed toward a possibility that sounded too radical to say with confidence. Something at Titan's surface could be consuming hydrogen and acetylene as energy sources. That matters because if you were looking for a completely alien metabolism on a methane world, those are exactly the kinds of anomalies that would make you stop talking like everything is normal. Not because they prove life, but because they create a pattern. hydrogen disappearing where it should not, acetylene missing where it should not. Now Webb adds more atmospheric anomalies on top of that old surface mystery. A single strange measurement can be a mistake. Several independent anomalies from different spacecraft across different years begin to feel like a system trying to tell you something. And that is why the phrase life on Titan suddenly feels less like science fiction and more like a scientific problem. Still unresolved, still dangerous to overstate, but no longer ridiculous. The burden is shifting. The challenge is no longer only to prove biology. It is to explain why Titan keeps producing chemistry and energy imbalances that repeatedly land in biologically suggestive territory. The truly radical part of Titan is not just that it may be habitable. It is how it may be habitable. On Earth, water is the solvent of life. All known biology is built on that fact. Titan's surface laughs at that assumption. There, water is frozen rock hard, while liquid methane and ethane fill lakes and seas. So if life exists on Titan's surface, it would not be life as we know it. It would be life built for cryogenic conditions, using different chemistry, different membranes, and different energy sources. A biological system operating in conditions that Earth biology would call completely lethal. And amazingly, Titan may not stop there. Evidence also suggests a subsurface ocean of liquid water and ammonia beneath its outer shell. That means Titan could potentially host two radically different habitable environments at once. One at the surface, built around methane chemistry, and another deep below, where water-based chemistry could operate in darkness near a rocky interior.